Okay, let's be a little nerdy now and take some looks at these relationships as they kind of relate. We're done talking, or we've talked about triangles, we've talked about all the sines and cosines, we've talked about the unit circle. Let's kind of start putting these kind of together a little bit in a relationship idea here. You know that if I've got this angle theta, the opposite side is sine, the adjacent side is cosine, and you know that in a unit circle the radius is 1. So that gives us the blue triangle that you can see here. That means if I use the Pythagorean theorem, and this actually is a Pythagorean identity, I get sine squared plus cosine squared is equal to 1. We're going to use this Pythagorean identity at a later time, but it's just kind of a neat little thing to be aware of. If you also think back, you can to geometry, you can know that this line is a tangent line, and the line over here is a secant line. And so if I look at this triangle in green, all the way down, all the way across, I then have a side of a triangle and the hypotenuse of the triangle, but I also have this side of the triangle is a 1. So I can create another Pythagorean identity from that. That tangent squared theta plus 1 squared, which is 1, is equal to secant squared theta. And that, again, comes from just the Pythagorean theorem, taking a look at this particular triangle here in green. And the third one, you can hopefully see this other triangle over here that kind of goes like this, comes on down, and goes on up. When I take a look at this, this triangle has a cotangent here. The side that is the radius of the circle is still 1, no matter where you're going to put it. But the other side here on the hypotenuse in this red triangle is actually the cosecant. And so when I look at this triangle, I can then again create this Pythagorean identity that says that the cotangent squared plus 1 is actually equal to the cosecant squared, based on the same Pythagorean identity. Okay? Just some interesting relationships that are coming about because we've taken triangles, we've taken the trig functions, we've put the trig functions into the unit circle, and now we can start exploring a little bit with the relationships that happen here. Just on a tiny little side note here, I just want to make sure that that we're all aware that when we look at complementary angles here, that this angle is 90 degrees minus theta. And it's also, if we're in radians, it would be pi over 2 minus theta. Okay, just so that that we're aware of what this angle is, right, on this side of the triangle that we were looking at in red.